Better than no applause at all.
No, yeah, I think that's worse.
Just in my mind, I feel better about it.
Just
I don't
act
either.
like it wasn't a pity applause.
An arc. An arc is a measured piece on the circle. It's basically a curved segment. An arc, think of this as a segment on a circle. Think of this as what we call a segment on a circle. But when you're on a circle, the segment itself is curved. Do you guys agree with that? Because you have to go around something, you're going around a circle. So you're on a curve. So a segment on a circle. What we do is we label them very similarly to what we have with segments and whatnot, but one very obvious difference. This stands for an arc.
Are you sure?
Pretty sure.
Not sure.
Very sure.
Not sure is very sure.
Not
right.
sure at all.
So here's what happens. You get two letters, and when you use two letters, it's always going to be shown as the shortest distance between those two letters. Okay? There's a reason for that. Because if I say segment, or if I say arc AC, I'm saying this arc here. Because that's the shortest distance. Could I go the other way around? Yeah, but it's longer to get there. So it's always going to be implied when you have two letters that you always go the shortest distance. If there's a third letter, it just means you're going a different direction, or you're following, it's telling you what direction to go to. Think about when we did polynomials. Trapezoid A, B, C, D, you're just going in order of the letters. Same idea. If I say, maybe if I put another dot here as a D, if I say arc A, D, C, that means I'm going that way to get there. The lettering just tells me direction. Does that make sense? It's very similar to what we did with angles and all that other stuff. Will there be times that you have something in between here where it's A, E, C? Yeah. It just means that that point E is somewhere in between it. But it just tells you the direction that you're going when you're walking through an arc, or when we have to eventually find measurements and eventually find lengths. Okay? So what we're going to work on today, or we're going to work on what's called arc measure. And then maybe towards the back half of Monday, we'll talk about what's called arc length. Two totally different things, okay? But it's, one starts with an M, the other starts with an L. What? This is fun.
Thanks.
So you have what's called an arc. Arcs are created by what are called angles. And today what we're going to look at are going to be called central angles. Where do you think a central angle is located in the circle? The center. You guys are so SMRT, it's ridiculous.
You're going to say
No. Central angle. Oh, did I go too fast on that? Were we okay on that? I didn't mean to click out of that too fast. Central angle. A central angle is an angle in a circle where the vertex is at center and the sides are radii. Bless you.
Thank you.
So this one would be ABC, angle ABC would be considered what we call a central angle, because the center is the vertex, B. The sides, BA and BC, are both radii. And the arc that angle runs into would be called arc AC. It runs into arc AC. We okay with that? Now, when we get into this a little bit further, we start talking about different types of measurements. Just like you did with angles. Remember how angles we had acute, obtuse, right angles, and things like that? With arcs, you can have the same idea. You can have what's called a major arc, or a minor arc, or something called a
Natural art.
semicircle. Now, I didn't ask this question yet because I'm hoping that you might know this. How many degrees does it take to get around a circle? Too many, very good. And otherwise, that too many allocates to what finite number?
6.
Otherwise, how many degrees are in a circle? 360. So, in a circle, there are 360 degrees in a circle. We all knew that. That wasn't anything different. In a semicircle, there's how many degrees? 180. Because a semicircle is half a circle. It's like your semi-annual clearance sale. The semi-annual clearance sale happens how many times a year? Twice. Or if you go to Kohl's, everything is always on sale. No, but it's kind of false advertising. Did you know that? They're being sued in California for it. If you ever look at, yeah, if you ever look at Kohl's in a Kohl's ad, you'll notice it always says lowest prices of the season, lowest prices ever. Well, if you research the prices of what it actually is sold for, the prices never change. If something like says MSRP on it's $55 and they're selling it on sale for $19.99, it's usually always $19.99. It's just a marketing ploy to get you to think that, oh, it's on sale, must buy it. That's all it is. Did you guys know that?
No. They used to do that movie.
Seriously?
They used to like pop popcorn. Like, people wouldn't realize it. And they said they're going to want popcorn. Then the movie theater got sued.
Wasn't somebody in here that was working at the Park District at the concession stand? Wasn't somebody in this class that was trying to get a job at the concession stand? I thought you were saying it, Topper. Were you, Thor? I thought one of you guys, might have been another class, the girls that sit in the middle or something like that. One of my first jobs was working at a concession stand for the Park District. And it was, it might have been my summer between my sophomore or junior year, freshman, sophomore year, or something like that. And what we used to do is, if you've ever operated one of those, the manual popping popcorn thing, not just put it in the microwave and press the button, where you add the kernels, you add the butter and the salt and all that too. Well, what they did before they actually partitioned a lot of that stuff out to save money is that they just put you had to just take a scoop of kernels, put it in there, and then you'd have to measure out the oil, measure out the butter, or whatever. But what we were told to do is that we would always add a little bit more salt than you needed. Because when you have too much salt, what do you get? Thirsty. And what do you sell? Pop. It's a marketing ploy, guys. It's a marketing ploy to get you to do stuff. Why do you think they sell lemonade stands when it's hot out? You don't see a lemonade stand today, do you? That was kind of a dumb example, but it's kind of a joke. But no, seriously, it's just a marketing ploy. Those are marketing ploys to get you to think that you should buy something. You have no interest in any like real world stuff here at all, do you?
No, I'd rather learn about that.
Me too, because it's actually useful. Not like circles aren't totally useful, but you know.
I
Thank
was
you.
just thinking about what you said.
You'd be surprised at the amount of things that, if you actually go back and research pricing and things like that, it's like Amazon. Amazon will say, oh, today's a special deal. It's 10% off what normal price is. But if you wait 2 days later, it's back to that same price that you thought it was on sale. They mark things up to mark things down. Happens all the time. Happens all the time. All right, you watch pricing on things, you know. It's just consumer things. Consumer reactive, yeah, it's just long. Anyway.
As long as I feel like I'm getting a good deal, then I'm okay.
And that's the idea. Are you really getting a good deal unless you really research what you're looking at?
Probably not.
And that's what's difficult. That's what's difficult about a lot of things, like buying cars and houses, and
Oh, see.
when you start looking
Maybe
at
you
big
do what
ticket.
Holden does. And you go buy the cars from the guy that barely speaks English. That's what Holden did.
Well,
You got a truck for $1,000. It still runs.
that's good then. So what's
2 years later.
let's do this. We have what's called a minor arc. A minor arc is the measure of an arc on a circle that's less than 180 degrees. It's an arc that measures less than 180 degrees. Okay. A major arc is an arc that measures more than 180. It's greater than 180, but it's less than, oops, I know that happened, sorry. But it's less than 360 degrees. Because if it measured 360 degrees, what would it be called? Circle. If it measured 180 degrees, what would it be called? Semicircle. In our class, we're not going to worry about anything beyond one revolution. Okay? We're only going to look at circles in terms of degrees when they go around one time. When we get to algebra 2, what would that be? Let's see, 24 pi over 3. Then we'll do stuff like this, where you're counting. I should do this separately. 3 goes into 25 how many times? 8. How many are left over? 1. Know how I said that mixed numbers are stupid? When we get to when you guys get to circles and we talk about the trigonometry in algebra 2, this is one of the only few places that mixed numbers make any sense. What we're doing is in terms of degrees. 0, 180, back to 360, 90, 270. When you get to algebra 2, so when we talk about it in algebra 2, we start at 0, 180, and we come back around to 360. So from here to here is 180. That means vertically you're at 90 degrees. Okay. We do that in terms of what's called pi. It's called radian measure. You ever press the button on the calculator that says rad and all your numbers get all messed up by sometimes? That means you're dealing with the circle's circumference. You guys all know 2 pi r for circumference, or pi r squared for the for area. That's where this comes from. So what you'll do in algebra 2 is count. This is 1 pi. This is 2 pi. 1, 2, 3, 4, 5, 6, 7, 8, and a third. And you can do all of your trig because that's when you worry about spinning around and going multiple angles. Okay. This year it's just within one ringy dingy. What's that? Actually, this is pretty simple because you remember the ratios of the 30, 60, 90 and the 45, 45, 90 triangles? 1 root 3 and 2 for the 30, 60s, 1, 1 root 2 for the 45s. Everything we do in trig in algebra 2 is just built off of those 3 angles. That's all it is. It's just 3 angles. Right? So you have major arc is greater than 180 but less than 360. Minor arc is less than 180. Minor arcs are usually 2 letters. More often than not, minor arcs begin with 2 letters. Major arcs would be given more, pretty much predominantly, with 3. Okay, it's given with 3 letters because it's telling you to go a different direction. 2 letters means go the shortest distance. 3 letters means go the long way. Okay, usually. So just for giggles here, if I say that this, I haven't told you that yet. Never mind. Yes, ma'am.
So you said the major arc begins how many letters?
3. Major arcs will have 3 letters. Because it's going to tell you, if it's a minor arc, if you have two letters, it always means go the shortest distance. But from time to time, you might see a minor arc written with 3. That just means there's another dot between the two. That's all. But if it's telling you to go the other way, that just means you're going the long way around, more often than not. And I've got a couple examples of that here in a little bit. So the reason that we're talking about these things that are called central angles and their arcs is because their measurements equal each other. Okay. What happens then is that we get the measure of a central angle equals the measure of the arc that it hits. The measure of the central angle is equal to the amount of degrees that the arc has. And that's kind of all we're worried about today, these central angles and the arcs that they run into. So if I'm looking at this angle here, this angle ABC, in the diagram it says it's 115 degrees, which means what's the measure of the arc AC? Bless you. It's how much? 115? Since the angle is 115, that means the arc that it hits is also 115. Oops. What would that have to equal then? How would you figure that out? Yeah. Remember, there's only a finite number of degrees in a circle. There's only 360 degrees in a circle. If you've taken up 115 of them, how many are left? Well, how many is that? Quantify it. That means going from here to here is 245. That's all that is. That's all this is today. It's basically putting things together and adding them up. Okay. So if I go back to the example we had on the board there, see how I had two angles that shared the same vertex and had a common side? So that means that I can add those two angles together. One angle's 12, the other one's 32. That means the whole angle would be 44. Well, that means you have one arc of 12, another arc of 32. How much is the arc together? That's all it is. That's all this is. You could add angles, you could add arcs. They do the same thing, do the exact same stuff with this. Okay? None of this changes from stuff that you've seen in the past. Everything that you've used before, you're using again. All those same properties and stuff like that. Let me show you an example. In the example here, we've got circle J, and it says that segment KM is a diameter. If you have segment KM that's a diameter, that means it cut the circle in half. Okay, so you have 180 on one side and 180 on the other. And it also shows that angle LJM is a central angle, and it measures 125 degrees. Since you know that, you can figure out the other angles as well as those arcs that are listed. Now, when I start with it as arc LM, that's just two letters, which means it's going to be the shortest distance between those two letters. Well, what's the central angle that creates arc LM? 125. So what's the arc? 125. Okay. Now, the next one, it says LMK, which means you're going from L past M to K. Well, what's this angle down here? 180. What's the arc? What's the arc? Going from LM to K. 305, very good. All you're doing is adding them together. Here's 125, we get from here to here. Oops. Here's 125, and I come back around, there's another 180. It's got to be 305. Or, there's another way to look at it. How many total degrees are in a circle? 360. If I know that half of it is 180, that means this part here, this left over has to be 55, right? Well, if I back out that chunk, what's 360? Subtract 55. 305. You get the same answer. You get the exact same answer result. It's just a matter of how you visualize if you want to add two of them together or just back one out. You'll go the same way. And what was the last one? KLM. It's got to be 180. What do we call something that measures 180? Semicircle. So it's 180 degrees, which is a semicircle. Okay. As you can see, this is pretty darn simple today, isn't it? Adding. Yay! I just did. Took 360 and subtracted 55. You go either way. It works. Okay. Let's try another one. Sorry, this one didn't turn out as nice. This was a 70. Okay. Take a look at this one. Again, you get a big picture style problem where you just start filling in blanks prior to answering questions. So take a couple minutes and see if you can figure this out. Ooh, excuse me. Nice, it was 60 degrees out.
What?
Oh, I froze.
It's sunny.
Yeah, that would be nice. So I know that the middle one's got to be 60 degrees. And now it's a matter of following the lettering. What's the measure of the arc AD? 70. Okay? Am I going to yell at you if you forget to put a degree symbol? No, because I will forget 90% of the time as well.
Oh, I forgot all of them.
It's okay. Don't worry about it. Seriously, it's not the end of the world. Okay? What about AB?
60.
60.
Last year, Mr. Judkins marked us down every time we missed one.
Yeah.
Because he's a meanie. I'm a nice
Yeah,
guy.
I
He
failed
used to
his
dock
class.
points for it.
CD.
180.
180.
Like missing degrees.
Judkins?
Yeah.
I know, that's why I failed his class last year.
BDC. 310. Very good. Now remember, you can do that two ways. You can add them up or just subtract out what's left over, just like you've done before with like supplementary and complementary angles. You do the same thing, guys. ACD.
290.
290. Ooh, excuse me. And then last but not least,
50.
very good. Do we need to make this any more complicated than we are right now?
No.
Good, then I'm not going to. Because next week we just add to this with some algebra.
Yay!
Same like we did before with segments and with angles. We started out with just adding, subtraction, addition, and attach. Guys, come on. And then after that, we just add in the algebra. So, that's what we're going to do. Because that's how we roll. Yeah.
3 months. Thing. Solid. I don't care, but he's like 3 months until then. You'd be good for us. Yeah, it's
Sorry.
fun.
On this one here,
Yeah.
what's that? No, are they not passing it up?
Yeah.
I only give you 4.
It was on the wrong side. It's still up.
Maybe, I don't know.
James, out of my DMs.
Honestly, most people are finishing this in about 8 minutes. Just do 4 through 24, okay? All right? It should not take you very long whatsoever.
Wait, 9 or 8?
Remember, minor arc is less than 180, major arc is between 180 and 360. If it equals 180, it's a, and if it equals 360, it's a circle.
Wait. Just totally.